Hello guys, welcome back. Today in this video tutorial I will be taking a new proximity sensor, that is TMD2771. Now to have a better perspective regarding the sensor, let's visit the website, that is controleverything.com, and here we have to search for this particular sensor and let's see what we got else from that. And as you can see, it's an ambient light sensor with 16-bit proximity detection, and these are some of its more prominent features which you can see on my screen. You can also have the ability to purchase the sensor from this website from here. Further, I will be interfacing the TMD2771 sensor with a particle photon, and for that I require a code. So go to resource tab and here comes the particle code sample. Now you can download the particle code sample as a zip file from this very site. Also, you can have the code from github.com, and the repository there is Control Everything Community. Now let's have a look over the hardware. We need to make some connections and let's have it. Now in the hardware section, first of all the requirement is of our particle photon, which you are able to see on my screen. And here comes an I2C shield. Now this shield is very useful in making connections with other I2C devices and rather easy connections, and it's also available on the website controleverything.com. Now gently press over the particle photon over the I2C shield and make a connection. The next thing we require is our sensor, that's a proximity and ambient light sensor TMD2771. Now this here is a connecting cable. Now make the connection among the cable and the sensor and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and for the same reason to the I2C shield. Now this here is a micro USB cable and it's very useful in making the power connection, and gently insert it over the power jack. Now we are all done with the connections. Now what do we require is to have a look over the particle code, and let's proceed how it interfaces. For the interfacing part, to find out the particle code, we have to log in to github.com, and here we have to search for the repository, that is Control Everything Community, which you are able to see on my screen. After that, here we have to search for the sensor TMD2771, and here we get it, and this here is a particle code. But let's have a look over the instructions we need to fulfill first to pursue this code. It says that we have to log in to a particle photon and set up the device according to the steps which are provided on this very link. Let's open up this link and see what we got. As you can see, relevant information instructions are there to set up the device. Please do it carefully. After that, we have to download or git pull the code, and on the online ID we have to copy the code, and build.particle is the online ID there. Here we have to create a new file, copy and paste the code, and then we have to save it. After that, the last part, in this part we have to verify and flash the code on the particle photon, and the code output will be displayed in logs at the dashboard, and dashboard.particle user logs is there where we can have the result output on the screen. So note it down carefully and then proceed to the code once again. As you can see, it's a .ino extension file. In this particle code, we have included application.h and spark wiring I2C.h header files, and we have defined the address of the sensor, that is 0x39. Here we have some initialization of some variables, as you can see, and in this word setup we have some set variables also. In this we have initialized I2C communication as master along with serial communication with baud rate equal to 9600. Now in the writing section part, we have selected enable register having address 0x00 or with 0xa0, and we have sent the command for set power on proximity and ALS enabled, which is 0x0f. Then we have selected ALS time register having address 0x01 or with 0xa0, and the command is a time, that is 101 ms, and it's 0xdb. After that, we are selected proximity time register having address 0x02 or with 0xa0, and we are sending a command for p time to set at 2.72 ms, and it's 0xff. Then we have a select wait time register, which is 0x03 or with 0xa0, and we are sending a command to set w time, that is 2.72 ms, and it's 0xff. And next we have to select pulse count register having address 0x0e or with 0xa0, and here we have to send a command to set the pulse count equal to 4, and it will be 0x04. the last command, writing command, in which we have to select control lister having address 0x0f or with 0xa0, and here we have to send a command to set 120 milliampere LED strength. Proximity uses channel 1 diode, 1x P gain and 1x A gain, which goes for 0x20. After that, the writing section is completed. Then we are going to read the data. As you can see in the void loop function, we are selecting the data register having address 0x14 or with 0xa0, and from this very register we are requesting and reading 6 bytes of data, which consists of channel 1 and channel 0 data, and along with it proximity data is there. Then we have the conversion of the data takes place, in which we have used several conditions and formulas which are clearly described in the datasheet for TMD2771. At the very end of our code, we have the output data to be displayed on the dashboard, which is ambient light, luminance and proximity of the device is there. Now, as you can see, we have the output to be displayed on the dashboard, and to show it practically, let's see. Now in the working environment part, first step is to copy this entire code of the particle as you can see on my screen, and after that we have to open up the build terminal as we have discussed in the instructions part, and here we have to create a new file as you can see on my screen, and here name it TMD2771 for the reference, and here paste the code and then save it. After that we have to verify and compile the code, and then we have to flash the code. While flashing the code, we have to check for the magenta flash on the Photon. As you can see, it's successful and the notification is there, which means we have the code which is ready to go. And to see the output, we have to open up the dashboard user logs, and here we will have the output in the form of proximity and ambient light luminance. Here it is, as you can see. It's almost constant because there is no major change regarding the intensity of light falling on the sensor. But when I place some object over the sensor, you can notice the ambient light luminance is decreasing but proximity of the device increasing. As I am moving this object near the sensor, you can see the maximum proximity of the device 1023. But instead, when I bring a light source near the sensor, you can see the increase in the ambient light luminance and the change in proximity of the device. As you can see, the change is reflected on the dashboard in the form of logs. There you go. So this is how the sensor works and responds. Now what do we require is to have a look over benefits, features and the applications of the ambient light and proximity sensor TMD2771. Let's have it. The TMD2771 family of devices provides digital ambient light sensing ALS, a complete proximity detection system and digital interface logic in a single 8-pin package. The proximity detector includes a digital proximity sensor, LED driver and IR LED, which are trimmed to eliminate the need for end equipment calibration due to component variations. Excellent background light rejection allows the device to operate in environments from sunlight to dark rooms. These features make it very useful for applications like cell phone backlight dimming, cell phone touchscreen disable, notebook monitor security, automatic speakerphone enable, and a lot many. This sensor can be purchased from the website controleverything.com, and you can have the code from the resource tab, and after that you can download the code as a zip file. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would make it clear that for any further queries, you can reach us on controleverything.com, and to post your comments, you can post on the community page. For blogs and articles which are relevant to this sensor and the code and the video, you can go to instructables.com, and to subscribe more video tutorials just like this, you can have a look upon our YouTube channel. I hope you enjoyed this video, and thanks a lot for watching.